Hello, my name is Raul and I'm a volunteer naturalist for Larimer County Natural Resources Department. And I'm here today at Devil's Backbone to learn a little bit about rocks. Normally you would be out here with us enjoying the sunshine and picking up the rocks, but right now it's not safe to gather in large groups. But we look forward to one of these days you guys coming out here and enjoying these hikes. Okay, so let's get started. Scientists that study the Earth's minerals are called geologists. And one of the things that geologists are very interested in is rocks. And out here at Devil's Backbone, we've got plenty of rocks. The interesting thing about rocks is that they can tell you a whole bunch of things about the planet we live on. Geologists put rocks into three separate groups. And each rock that goes into the group has a lot in common with the other rocks that are in that group. Once you figure out what group your rock is in, you can begin to know about a whole bunch of things in it or about it. For example, you'll figure out how did it form into a rock, where did it come from, and in some cases you can even figure out how old is this rock. The first kind of rock I want to talk about is called an igneous rock. We call it an igneous rock because it came from fire. And igneous comes from a Latin word ignis, which means fire. Now these rocks were once part of the Earth's mantle. The mantle is a layer of molten rock way down beneath our feet. In Colorado, it's about 20 miles down. That molten rock is called magma. But sometimes that magma comes up here where we are. How do you think that magma comes up here where we are? So these rocks that used to be part of the magma, how did they get up here where we are? We live on a hard layer on top of the magma, a hard layer of the earth. We call it the crust. Well, this magma somehow found a crack in the crust and it came up. Sometimes it blows up into the air, sometimes it just oozes out underwater, and sometimes it just oozes out on top of the ground. Once that magma gets up here where we are, we call it lava. And what I'm holding in my hand, part of them, are what we call lava rocks. And they look like foamy little rocks. They can be brown, they can be red, they can be black. And one thing you'll notice about these is that they're very dull. In other words, this lava cooled off so quickly that the minerals in the lava, in the molten rock, didn't have a chance to form crystals. So you can hold it up to the sun and there's no sparkle at all because it cooled too fast. Now, this doesn't always happen. Sometimes this magma can't find a crack to come all the way to the top, so it gets stuck in the crust. Now, it's away from the mantle, but it's not on top. So it's still hot, but it's cooling very, very slowly. So slow that it takes millions and millions of years to go from a molten rock into a hard rock. Now, what happens when it takes that long? You have something like granite, a very common rock. But when you hold up a piece of granite to the sun, you can move it around and you can see crystals. And the reason we have crystals is because all of the different minerals that make up the granite had a chance to find each other and stick to each other and form crystals. Crystals take a long, long time to form, and you can only get them when it takes a long, long time for the granite to cool. The second kind of rock I want to talk about is called a sedimentary rock. Now you can figure out how a sedimentary rock was formed by stopping before you finish the word. Sedimentary rocks come from sediment. Now this sediment is the cause that we can get fossils. Sedimentary rock can contain fossils. In fact, it is the only kind of rock that can contain fossils. Now, how did these sedimentary rocks form? Well, from sediment, like we said. So, we get the sediment from oceans, from creeks, we even get them from sand dunes, where one layer of sand or mud laid on top of another layer, and they began to lay so much that the bottom layers were just squished and turned into a hard rock. Now, these rocks are not as hard as the other two kinds of rocks. We'll see that in a few minutes. The third kind of rock I want to talk about, and the third group that geologists study, is called a metamorphic rock. This time the word doesn't come to us from Latin. This time it comes from Greek. The word metamorphic comes from two words in Greek. Meta, which means change, and morphos, which means to change form or to change shape. So you get metamorphic. I know you guys like to study bugs. So if you'll think back to the bugs that go through metamorphosis, where they go from a caterpillar to a pupa to a butterfly, that's the same idea. It's changing shape. So a metamorphic rock is a rock that has changed shape. So where did metamorphic rock come from? Well, it was once an igneous rock, or it could have been a sedimentary rock, or it could have been another metamorphic rock that went through the process again. So how do these rocks become metamorphic rocks? Well, one way is they can get squeezed underneath by a tectonic plate. Now these tectonic plates are huge chunks of the Earth's crust, bigger than our continents. They go off into the ocean and they float around on top of the magma, and they shift slowly, about as fast as your fingernail grows. That's how they're shifting, and they can squeeze rocks. And these igneous or sedimentary or even metamorphic rocks can get squeezed, and they get so hot because of the pressure that's on them. Or maybe they're pushed down close to the magma and they begin to get hot, and this causes the minerals to shift. Now keep in mind, they are still in the crust. They're not in the magma, so they don't become igneous rocks. If it got down into the magma, it would become an igneous rock, and we would lose all evidence of where it had been before. So one of the things you notice about metamorphic rocks, number one, they're very hard, but usually they are in layers because they've been squeezed so hard that the only way that the minerals can withstand the pressure that they're under is they begin to migrate and form bands, and oftentimes you'll see the bands inside of the metamorphic rock. In fact, if you drive up from Loveland up to Rocky Mountain National Park, as you go through the Big Thompson Canyon, all that dark and light streaks that you see, that's metamorphic rock. We call it banded gneiss, G-N-E-I-S-S. I think it's a German word for banded, in fact. So you can find metamorphic rocks in a lot of places, but you'll know that it was once something else. Okay, I hope you enjoyed this virtual tour of some of the rocks that we have out here at Devil's Backbone. The next time you go out and you pick up a rock, or you find a rock even on the side of the road, you can pick it up and try to figure out what group it belongs to. Once you figure that out, it's no longer just a rock. There's a story to that rock. Where did it come from? Was it hot? Was it wet? Was it laid down? Was it squeezed? Was it twisted? So there's a story behind every rock. So I'm hoping that as soon as you get a chance, you're out here at Devil's Backbone, and hopefully it'll be safe to get in groups, and we'll be out here with you. So in the meantime, go out, enjoy the trails, pick up some rocks and take a closer look at them, and don't forget, bring water. This is Colorado.